Hi, hello everyone. This is Nikita, and today I have come up with a video on rule resolution. In my previous video, I talked about rule availability because that was one of the core concept which you need to know before you understand rule resolution in particular. So in this video, we would talk about rule resolution and how do you come up with the perfect rule which would be executed at a given time. So that's the main motto of this video. So let's start. So basically, what is a rule resolution? It is a search algorithm that the system uses to find the most appropriate instance of a rule to execute in any situation. Okay, so it's basically algorithm. Okay, to come up with the correct rule, we use some steps. Okay, one by one, and eliminating the unnecessary rules in between, and that's how the rule cache is built up. So we will discuss all of these in this video. Finds the most appropriate rule instance to execute at any point in time, and it applies to most rules that are instances of the class derived from the abstract rule based classes. So obviously rule resolution is only for the rules, so some data instances will not come in the purview of rule resolution. So basically all the rules which are in the hierarchy of abstract rule dash classes would be covered in rule resolution. So that's what is rule resolution. Coming to what are the input to the rule resolution and what is the output we get. So what should be the input? We should know the rule keys. Okay, so every rule has a unique identifier. So we should know about all of those, and then the applies to class, the rule name and the rule type, rule set name, rule set version. All of these are the input to the rule resolution. And the other thing is you should know your operators rule set list. Okay, so whenever you log in to your application, there would be some rule set stack which would be built up according to the application you have access to, the rule set you have access to, all of these. So basically your rule set list is important before we start with the rule resolution, and the class hierarchy of the rule in question. So the same rule with the same name can be in different classes. Okay, so some classes can come up in the hierarchy in which we are executing that rule, and some will not. So we should know what is the current class and the hierarchy of the rule in question. And then the circumstancing, right? Same name of the same property, same class, only the version is different. Not the rule set version, is the circumstance version. As in, what is the unique thing which differentiates this particular rule from the other rule? Okay, so this is what circumstancing is. So we should know the circumstance such as the value of a property, time and date restriction, whatever the restrictions are there for that particular rule. Then the availability of the rule, which I had talked about in my previous video, whether the rule is available or it's withdrawn, it's blocked or whatever it is. So we should know about that also. Then the user's access role and privileges. Basically, the user has the authority to run that rule or not. It has the privileges to run the rule or not. Those also come under, as an input to the rule resolution. We should know about that. And then what is the output? Output is basically is the first rule found that matches all of the input criteria, whatever criteria we have given. Okay, and then on top of that there would be a rule set rule cache would be built up. Okay, so whatever is the first rule which matches all the input criteria would be the output to this particular algorithm. Okay, so coming to rule availability, which I had discussed in my last video, I would advise you to please go and check out that video if you have not done it already. So I have discussed about what are available, not available, withdrawn, blocked, all those rules, because on the basis of that we would come up with the elimination process of the rules. Now this is basically how do we populate the rule cache. Okay, so first we choose the rule with the correct purpose, right? Suppose we want a section to be shown right now. I want a I'm finding the list of the section which I can execute at this point in time. So I have to see whether my rule has the correct purpose or not. I'm actually looking for the section or I'm just looking for something else. So I have to find the rule with the correct purpose. If I'm looking for a section, I should get the list of the section with the name, with the same name. Discard the rules that are not available, then I will discard whatever, the availability of that particular rule has been set to not available, then I will discard that rule. Then I will filter the rule set and the version user has access to. As I've told you that the rule set stack is one of the important factor in determining whether you can run that rule or not. So I have to see that my operator has the rule set version and the rule set access to the rules or not. Okay, so I'll eliminate ones which I don't have access to. Then I will discard the rule not in inheritance path, which I have discussed about class inheritance and pattern inheritance in my previous videos. So basically whichever doesn't come in the hierarchy, okay, in the class hierarchy or the inheritance path, then I would discard those rules because that will never be run. Then I would rank the remaining rules, whatever rules I have, after all the elimination I've got, I would rank them on the basis of certain criteria, and then the rule cache would be set up. Okay, so this is how it is. So this I would explain with an example. This would be the set of rules, which I would go to the next part where I would discuss all of them. Okay, so basically this is the all the rules which I have got it. Okay, those are with the same name. Obviously it's the rule resolution, but all the rule will have the same name. Okay, and that will have the same purpose. Okay, so now I am looking for a section, so all of them are section, all of them name is create request. Now applies to class and availability, these two things can change. Okay, so basically now what I would do is all these rules you can check the applies to class of them. Some of them are purchase request, some of them are in purchase order, work purchase order, then some are in the work pool, then directly organization class, then some other classes. Okay, so this is my set of rules which I have been given, and then there are different availability set to them. Some are not available, some are available, some are withdrawn, all of these things. So that's it. Now I would see one by one how will I eliminate the rules to come up with my cache. Okay, so the first thing is discard not available rules. The rules which are set as not available, whose availability condition has been set as not available. Okay, so now what you see is all the rules, all the sections which are not available, I can eliminate them. So whatever is in yellow, basically I'm eliminating them. Okay, so these are not available, I can eliminate this, I can eliminate this as well. Okay, I will not see the classes, but since it is not available, I'm sure this will not participate in my rule resolution process. Okay, so I can eliminate. So these three have been eliminated. Now the second part is discard the rules which are in inapplicable rule set. Okay, which does not come in the operator rule set stack. Okay, so now I can give you the example. In here the operator rule set stack, I have set it to a purchase. It has access to basically purchasing rule set of O2 O1. Okay, so the major version is O2, minor version is O1. This is my operator has access to. Now it also has access to TGB rule set O1 O1, and there is no quoting or SAE rule set in the stack. Only these two are there in the rule set stack, not the other ones, right? So let me start one by one. Coming to this one, right, you can see the rule set version is O2 O1, O2 O2 O1. So is O2 O2 O1 in my operators rule set stack? This is the one which I've told you, O2 O1. So this minor version is more than the operator has access to. So obviously the operator can never run this rule. So I can eliminate this particular rule. The second one is O1 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 purchasing rule set. But since my operator has access to the higher major version, which is O2, it will never run the rules of O1. Okay, so O1 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 will not participate in my rule resolution right now. So I can eliminate this as well. Remember, I have not eliminated this because it has been set to withdrawn. That will come in the later part. I have only eliminated this because it does not come under my rule set stack. Okay. Now this next one, all these can take part because this is O2 O1 O1. Okay, O2 O1 O10. So anything which is O2 O1, major version is O2, minor version is O1, that can take part in rule resolution. So this too will take part. This will also take part. Okay, since this is O2 O1 O1. Now the next is purchase order O1 O1 O1, right? But I've told you, since my rule set stack has O2 O1, it will never run the rule of O1 O1 O1. So I can eliminate this as well. This all is okay because it's under O2 O1. Now this particular TGB class has O2 O1 O1 O1. Again, it will not take part. I can eliminate this as well. This one is O3 O1 O1. But my TGB rule set, I have to see what my rule set stack has. My rule set stack has O1 O1. It does not have O3 O1. So I will eliminate this as well as this. Okay. I can keep this because it is O1 O1. This will take part in my rule resolution. Now the last three, these rule sets, my operator does not have access to. Okay, so I can eliminate these three as well. Okay, so these many rules have been eliminated now. Now my third step. Third step is discard rules outside the class hierarchy. Okay, the rule resolution algorithm examines the applies to class in the list of candidate rules if the remaining candidate rules are in the referenced rules inheritance hierarchy. Okay, so what I mean by that, let me first go back and explain what I told you from the very beginning. What was the first step we did? We discarded the not available rules. What was the second step we did? We discarded the rule which does not come under the operator's rule set stack. Okay, the operator does not have access to. Now the third one is discard the rule which is outside the class hierarchy. Okay, basically this section has been called from where? This section has been called from flow action, right? So flow action class would determine what my inheritance hierarchy would be. Okay, so my flow action, if it is in the purchase request class, if it is in this class, right, purchasing request class, it will never go and call the purchase order section because those does not come under the hierarchy. Both are parallel. Okay, purchasing work, purchase request, and then purchasing work, purchase order. Okay, so these does not come under the inheritance path. So I will discard this as well. Okay, so purchase order one is discarded. Now the rest. The fourth step is discard withdrawn rules and rules affected by it. Okay, so basically all the withdrawn rules and the rules which have been discarded because of it being under the inheritance path of the withdrawn rule. Basically we have to discard the withdrawn rules and all the rules which are in the same rule set and same class and in the lower versions, in the lower rule set version would also be discarded. Okay, So when we check in this list, we have this withdrawn rule. Okay, this is in O2, O1, O10 and purchase request class. So this is withdrawn. What does it mean? It means it will this will get withdrawn obviously, but this class rule will also get withdrawn. Got my point? Since it is the same class, same rule set, this is the higher version and this is the lower version. Since the higher version is withdrawn, the lower version will also get withdrawn. Okay, so now these are withdrawn. What is the rest I have? I have these two. These are not withdrawn, so this would take part. Coming to this one, O2, O1, O1, and this is in the TGB purchasing work class. This is withdrawn. O2, O1 is withdrawn, so it would get eliminated. Is there any other rule which is lower than this? No. So it is only this one will get eliminated. Now I have some remaining candidates. Okay, this one is already deleted. Delete. Okay, so now I have some candidates. Okay, now these remaining candidates have to be ranked on the basis of the below criteria: class, rule set, circumstance, circumstance date, date, time range and version. Class, you know, like whichever is the higher, like if it is specialized, it would take precedence over the other, which are the parents. Okay, now the rule set, obviously the rule set with the higher, you know, which are there in the operator stack in the higher place, it would take precedence. And then circumstance, if there is any specialization in circumstance done on any rule, it would take precedence over the default rule. Okay, then there is a date, time, range and version. Version is a rule set version. Okay, so now I've ranked them. Now you can see this circumstance is taking precedence. There is a qualifier here and in this also. And this is a base rule. It doesn't have any qualifier, but it is in the same rule set version. After that we have TGB class. It's in TGB rule set and O1, O1. So this is all about ranking them. Now I have 4 rules, but what I have to do, I have to find the default rule candidate. It is the first rule candidate that has no qualifier. It is the last possible rule to be executed as it matches any additional request for this rule. So basically we have to find the last possible rule to be executed as it matches any additional request for this rule. So here you can see that these are 2 circumstances, that's okay. But this one, this is in the work class, it's in the rule set and O2, O1, O5. Okay, this one will serve the purpose of any additional request. If suppose now I want to call the section, you know, in the same inheritance hierarchy, even if it doesn't matches any qualifier, any circumstancing, still this would be the default rule which would get executed. It will never go and execute this rule. That's for sure, right? Because that's in the like lower inheritance path. So that will never get executed. So the result of rule resolution is this. You have 3 rules, okay? Two of them have the circumstances defined. So circumstance rules will only be called when that satisfies the request, okay? So if suppose you have some, this will always be checked first. Always whenever a rule resolution picks up and tries to find the rule which matches their criteria, it will check whether the circumstancing is satisfied or not. If suppose circumstancing is not satisfied, even this and then date, both are not satisfied, then it would go and call this default rule. Okay, so this is called a base rule basically, and these are the circumstance rule. So this is basically the result of the rule resolution. This is just the creation of the rule cache. Okay, now after this, what is done is you check whether your rule is, have the privilege, have the required privileges to run or not. Okay, and if you have, then then you can run that. If it is blocked, then obviously you will shown in the screen that no, you cannot run this because it is blocked. So that's how the rule resolution will work. I hope this gave you a little idea on how it determines the correct rule to execute at any given point in time. All these things you never have to do by yourself. This is an algorithm built in PEGA, and it determines the correct rule for you. But it is necessary to understand how this is done. Otherwise, you might get into a trap that why this rule has been executed, and suppose sometimes you have to withdraw the rule, right? And then you don't know why my rule is not getting executed, why the other rule is getting executed. There can be multiple scenarios where we would require some other class rule to execute rather than the implementation class. So because of all these things, it is very important that you know how this algorithm works and use this to your advantage. I hope you liked my video. I would wait for your feedback on the same. Thank you for watching my video. See you again in my next video. Till then, see ya. Bye bye.